though. So the first screen I'm going to talk about is the option input screen, particularly in new construction and retrofit analysis. So right now I'm in new construction mode, and like Craig said, in the upcoming bug fix release, this drop-down is actually going to disappear here, and it's going to show up on the splash screen so that your project is actually going to be in new construction or retrofit mode. But with the current release that's out, there's currently a drop-down here, so this is displaying that I'm in new construction mode. And what I want to show is, for the most part, in new construction analysis, things are unchanged relative to how they were, with one exception. So, for example, if I come down to the central air conditioner category, what do we have listed here are air conditioners SEER 13 or higher. In the BEopt library that we ship, we actually have some additional air conditioners that are less than SEER 13, a SEER 10 and a SEER 8 air conditioner, but they're not showing up in new construction. And so one of the things we now do in BEopt version 2 is we tailor the interface so that in new construction, options that do not meet the federal minimum standards or that cannot be purchased on the market do not show up in the interface. So likewise, in some of our appliance categories, like the refrigerator, there will be additional options that are not showing up because you cannot purchase these appliances anymore. But if you were in retrofit mode and you were describing your existing building, then you would see some of these additional appliances and equipment options show up. So we're trying to simplify the interface for new construction analysis when you're doing that. Aside from that, like I said, new construction analysis is relatively unchanged relative to version 1. Most of the work that we've done is trying to improve the usability of the interface and the appropriateness of the analysis for retrofit buildings. So I'm going to go ahead now and switch it over to retrofit analysis. And what you'll see now is that we have two tabs. So BEopt version 2 is a little bit different than version 1 in that we split apart your existing building versus potential retrofit packages or designs by tabs. Previously, the existing building was a set of radio buttons that showed up, but we're trying to make them a lot more explicit here in version 2. So you have a tab called existing building where you describe the existing building. And so, for example, if I go back to the central air conditioner category now, you can see that the SEER 8 and the SEER 10 options are showing up. So now you have not just options available for new construction, but also older technologies that show up. Let's go ahead and say that our building let's say our existing building actually has a SEER 15 air conditioner. When I then switch to my design and want to evaluate potential retrofit packages, you're going to see that actually the options made available to you here are filtered based on what you selected for your existing option. So now you actually see options only making improvements relative to SEER 15, and the SEER 15 option is selected by default. So basically we're saying that if you select an option for the existing building, SEER 15, we're going to make that sort of the do-nothing situation for your design as a starting point. We're going to say, make my design as similar to the existing building as possible. So select the same option, and then you can choose to deviate from that as you want if you want to evaluate upgrading an air conditioner. So, for example, if I went back to my existing building, and generally speaking, you would want to be defining your existing building first. So instead, if you had a SEER 14 and you come here, BEopt's going to default to, again, the do-nothing situation of you're going to continue to have SEER 14. One interesting thing, however, is that if I go back to the existing design and I now choose a SEER 10 air conditioner, now when I go to my design, the SEER 10 air conditioner actually isn't going to show up. And the reason for this is that the CR10 air conditioner is not something that meets the federal minimum standard. And so what that means is that because we perform life cycle analysis in BEopt, so we're looking at energy consumption and cash flows over the next 30 years or however long of an analysis period that you set in BEopt, we know that at some point this CR10 air conditioner is going to, based on its sort of average lifetime and the age which you can specify for the equipment. So based on the remaining life of the equipment, we know that once that equipment dies, you're going to have to put in a CR13 or better at that point. So the default analysis would be that, so in this example here, we have a lifetime of 19 years and an age of 10. It sort of defaults to half the lifetime. And maybe I'll just go ahead and change that to 15 years, for example. So this is what I had entered. I have 4 years left on my CR10 air conditioner. And so my design, what it's doing by default, is trying to do the minimum possible, which is to say that at wear out of my CR10 air conditioner, I have to at least put in a CR13 air conditioner. Now there's a couple ways that you might make use of this analysis. One is that you could evaluate, or what I should say is that it's particularly important to capture this effect because if you were to, let's say, come up to the walls category and you were investigating putting in improved wall insulation. So your existing building, let's say, was an uninsulated wall and you're investigating the cost effectiveness of blowing in cellulose up to R13. It's important that the analysis take into account the fact that you shouldn't be evaluating the improved wall simply with your CR10 air conditioner if we know in just a few years it's going to wear out as it is in this example. And so BEopt would actually run two simulations, one with the improved wall with the CR10 air conditioner for 5 years, and then another simulation with the CR13 air conditioner for the remainder of the analysis period.
4 years.
Or 4 years, sorry. Thank you, Craig. And both of those simulations then are taken into account in the energy consumption and savings that BEopt would present to the user. So this is something that we think is really important in evaluation of retrofit upgrades that is pretty unique relative to sort of the world that we operate in for new construction. One thing you can also do is you could also, so like I said, for other technologies like wall insulation, it's important that you capture this effect. But even in this category, you could say, well, what if I wanted to have one design where I look at replacing my air conditioner today, and I wanted to create another design where I compare that to replacing my air conditioner at wear out. You know, so what if I let my CR10 air conditioner last as long as possible before I do my upgrade to CR15 versus what if I upgrade immediately today? And there can be HVAC downsizing interactions with this and cash flow interactions, and so you can get a sense of the cost effectiveness of upgrading technologies today versus doing them at wear out. So we're trying to provide the user with a lot of flexibility in their interface to do these types of what-if analysis.
So just to be clear here, this column of data that is labeled replace, this refers to the existing equipment, and the most conservative thing is assume that it gets replaced when it wears out, at which point if you upgrade it optionally to a higher SEER equipment than the minimum federal standard, at that point you had to buy a new air conditioner anyway, and so the cost associated with the energy efficiency is the incremental cost of the more efficient air conditioner. If you select replace today, that's an early replacement where you're taking an air conditioner that has maybe 4 more years of life, and you're saying for the sake of energy efficiency, I'm going to consider replacing it before it wears out. In other words, replacing it today. But that definitely comes at a cost premium. And Scott, were you going to describe the situation with walls, for example, where we don't see lifetimes and wear-out options?
I wasn't going to. I guess I can. So for envelope measures, generally speaking, you don't have the same choices in the interface about having to specify whether you're going to do the installation at wear-out. There sort of is no wear-out event for an uninsulated wall, so there's no choice about whether you would do a wall upgrade in the future or at wear-out or today. And likewise, envelope measures, generally speaking, last a very long time, so we don't show lifetimes or ask for the age of this equipment because it's not needed in analysis. These inputs, generally speaking, only show up for appliances and equipment type categories.
So in the envelope type, the cost of the measure is the cost of the measure because it's done for the sake of energy efficiency, the upgrades.
So here I have now set up 2 different designs. One where I investigate upgrading to a SEER 15 air conditioner wear out, and one where I investigate upgrading to a SEER 15 air conditioner today. Now the question is, what do you want to compare that to? If you wanted to get energy savings for these 2 different designs, what is an appropriate reference to compare to? And in BEopt version 1, let's see, I need to think of what we had in BEopt version 1. I'm not sure I can exactly remember what we had in version 1. I think we had just the existing building as is. But what we've done in BEopt version 2 is we've introduced a new reference that we call existing, but with minimum replacements. So I'm going to go ahead and select it, and when I do, a reference tab shows up here so that you can view what options are being selected in this. And this is an automated reference where essentially it's the existing building, except again in situations where we know that the technology that's in the existing building is not going to last for the entire analysis period. So again, here we are in the air conditioner category, and what it has selected is SEER 13 at wear out. That's the minimum, it's sort of the do-nothing baseline that if this building simply upgraded as needed to meet the minimum the known federal minimum standards, this is what they would have to put in at wear out. And so the savings that you see for putting in these higher efficiency air conditioners would be relative to this reference baseline. And the reason for this is because it's a little bit unfair to say, well, I want to see energy savings for these upgraded air conditioners relative to a SEER 10 air conditioner for the next 30 years, when we know that's not the likely situation. So this is a automated reference that tries to make appropriate selections to create this baseline scenario where it's essentially the existing building, but with a few replacements to account for these federal minimum standards, these known standards that are currently in place. And this is actually a concept that, for those of you in California, the California Public Utility Commission has something they call a dual baseline, where they have a similar type analysis when measures are replaced before their end of life. They have sort of 2 different baselines that they calculate energy savings, and we've sort of streamlined things a little bit to put it all into one reference, where your reference is changing over time, and that's part of the life cycle analysis. So I think that's what I wanted to say about retrofit analysis in BEopt version 2. I'll get some more things about where some of our measures come from and how our costs are working in version 2. It's quite a bit of change versus version 1. But I think at this point we'll open it up for any questions that people have.